This conference will now be recorded.
Okay, so welcome everyone. So today we're gonna look at Fluidsim and Ciros. How can we use Fluidsim with Ciros? And so basically the concept here is, how does a circuit diagram relate to a machine? Imagine that you have a machine that consists of electrical wiring and also consists of pneumatics. You could build a circuit, a pneumatic and electric circuit of those in Fluidsim. So at times there can be a disconnect in terms of looking at the real machine and looking at the circuit in Fluidsim. So today's webinar, it's giving us an insight on how we can link the two so that when something is moving on a real machine or on the machine, we also see the impact in the circuit, in a simulation mode. So this is a very useful tool for those that may be still studying pneumatics and pneumatic symbols, AC symbols, and also studying electrical wiring. So we're going to start off with a simple thing, a pneumatic circuit, and then we will use an internal PLC in Fluidsim to control such a circuit, and then later on we will then link this circuit with a machine in Ciros, and then we will then run both in simulation and see how they operate. So we're going to start with a simple circuit here, pneumatic circuit. We will use a double acting cylinder with a solenoid operated valve, 5-2-way ideally. Of course, we will need the supply with this, which will be the compressor, and we will need the service unit. Here we are. So now we're gonna put labels on the cylinder, actuator labels. So we're gonna say 1 is 1, which will then start at 0 and end at 10. This is the stroke length of the cylinder. So this switch will be active when the cylinder position is at 0 millimeter to 10 millimeters. And the second one will be from 90 to 100. This is to indicate that the cylinder is fully extended, or to signal to the PLC that the cylinder is fully extended. Right now, the valve itself, so this is a solenoid valve. We're going to label it M1. And that's about it. Now we're going to start with the PLC or electrical wiring. So here we're going to need a PLC. Let us take one with 16 bits of inputs and 16 bits of outputs. I'll explain later why we're taking that one. So there's different. There's also one with more bits. I think it's 3 bytes. Here we have 2 bytes, and there's also one with 1 byte inputs, 1 byte outputs. All right. Now we're gonna look at the circuit, the switches, so that but what's also important is that I must maximize the size of this PLC so that I can have enough space in between. So I'm going to make the X scale 1.5. Oh yeah, and I must not forget power supply. So we need 24 volts, and we also need 0 volts here. So we will have a start and a stop button. And then we will have one S1 and one S2. Stop button, one S1 and one S2. They should be here. Yeah, an S1, the limit switch. And one S2. Link and display. By default, it does that. Okay, so now we need a solenoid valve here. We need a solenoid for the valve, which is going to be M1, so that the PLC can control this solenoid of the pneumatic solenoid valve. So we're going to go to relays, and there's the valve solenoid. I'm going to make it output 0. Okay, and then now we're going to look at the PLC program. So there's two options here. One could use function block diagrams, or a PLC programming language in Fluidsim that almost resembles function block diagrams. There's also a sequential function chart. I will use sequential function charts because it's much more flexible as compared to function block diagrams, and also because it's actually a step programming language, so it goes step by step. So this is a very good thing. Okay. So we have step 1. These are the conditions, and then this is the action. So we're just going to connect these 3 things here. Yeah. Then we have step 2 with its action and its conditions, and then we have step 3. So we will define what happens at each step just now. We need to make step 1 initial step, so we just have to come here and select that it's an initial step. Okay, so in step 1, there isn't any action for this that we need. If we had lights, for example, we could add an action to call it lights. So we can leave it like this. What is important is to have a start as a condition, and the one which is that the cylinder is retracted. So we're going to have an end function here. So those are input 0 and input 1, if I'm not mistaken. Input 0 and input 2. So one can say I0 and I2, or you can come here to variables and say I0, and then click end, and then variable, and then I2. All right. There we are. So then we will have.
So, Treasure, that's the transition from step 1 to step 2.
Sorry?
To understand correctly, Treasure, that each one of these 1, 2, 3, those blocks are steps. And to get from a step to the next step, there's a condition. And that condition at the moment is I0 and I2.
Precisely. Yes.
Okay, and those I0, just show me again what you've wired up to the PLC. So
let me
I0
do this,
is...
I'm going to move it here so that we can look at like this.
Okay, very good. So I0 is the start button, and I2 is the limit switch on the cylinder. Okay, got it. Thanks.
So here we will have the action as output number 0 because this is linked with M1, because we want those two conditions to activate the cylinder so that it fully extends. And then once it's fully expanded, input number 3, which is 1S2 limit switch that cylinder is fully extended, will turn on, and we will have it as a condition here. This is I3. And then in I3, what then we do is we need to, so this is the thing about this sequential function chart that we have here, or sequential function chart, excuse me, is that Q0 will remain true up until the condition is met. When this condition is met, the program will jump to step number 3. Immediately when it transitions to step number 3, the condition, the action that was active in the previous step will be inactive, which means that Q0 will turn off. In other words, when I3 is on, when 1S2 turns on, Q0 will turn off. So from this point on, we can actually go back to the initial step. So that when we go to initial step, we wait again for the conditions, which will be the start and 1S1. So yeah, and that's pretty much it. Let us test this.
Oh, you need a push button on there rather than a self-actuating.
So I went to general switches. We need manually operated switches. We need a push button here, which we will also label start. That's better. So when M1 turns on, so I need to M1. Yeah, it's important to link this with the electrical circuit diagram with the pneumatic circuit diagram. We use labels to link them. There we are. Okay, so now one may think, all right, what would this look like in a real life or on a real machine? So particularly in the situation of limitation in terms of being able to go to different places to look at.
Treasure, could I just see the GRAFCET PLC and the instruction list, the sequential function chart at the same time to see how Fluidsim is simulating both?
Yes. So I think it's gonna cut now because it looks like this number which I've dialed, it's not at all free, so it might cut us any moment. It's pretty fast. Let me see if I can slow down the simulation. So there's a simulation where I can actually adjust the speed of the simulation. This should be perhaps here, options, simulation.
Slow motion factor, yeah, make it 5. That's perfect, make it 1 to 5. His connection has dropped. Okay, it did warn us about that. Right. Anyone else got Fluidsim running? I don't have it yet.
Hello, host is Hannes here.
Hi,
I don't
Hannes.
have Fluidsim running. I know that Darby is also doing something similar on the PLC course and on the other Fluidsim courses. That he is showcasing the GRAFCET and the PLC portion of Fluidsim as well. So
Okay.
on the Fluidsim course that we presented, we also did something like this to show just quickly how to
With a
connect the
built-in PLC, with the GRAFCET
the built-in
PLC.
PLC. Yes, yes. So that works quite well, and a lot of interest from the guys. Now I see Treasure is back. The one question that most of the programming guys had was, can you import an existing program, let's say from Codesys or from Siemens, to Fluidsim and to the GRAFCET PLC, of which the answer is obviously no, unfortunately not. So this is only for simple pieces of your circuitry that you can simulate from the PLC. But the one question and what the guys would have really liked if they could import the complete program into Fluidsim, but unfortunately that's not possible.
Yeah, you've got to rebuild that whole GRAFCET, that sequential function chart. You've got to rebuild it from scratch.
That's it.
What will be interesting here is to see how the link is made into the virtual reality of the Ciros, of the virtual MPS station. Has Darby and Charles, have they tried a virtual MPS station already with Ciros? Do they know Ciros?
They have not. Is that then? Oh, we can hear you, Treasure.
Okay, thank you.
All right, we can carry on with the discussion later.
Okay, great, thanks, Hannes.
Yeah, so I'm glad that you can hear me now, because I've switched to my PC now, so if you can hear me, this is excellent. So I've overheard what your discussions a bit there, Hannes. Just wanted to also give input. It's true that it won't be possible that we can take PLC programs from either Codesys or Tiaportal and put them in Fluidsim, simply because Fluidsim, this is stored as a Fluidsim project, and they're just different hardware, software altogether. But what is possible though is you can build an electro-pneumatic circuit like this, and instead of using this PLC, you could use a PLC sim from Tiaportal, and then use Tiaportal to basically control this electro-pneumatic circuit, or use Codesys to control electro-pneumatic circuit in Fluidsim. That is a possibility.
So you do that through an EasyPort, or how do you do it?
It doesn't require any hardware, so you wouldn't need a PLC, a real PLC. You wouldn't need a real anything actually. You just need software. So you would do it. You would use OPC. This is an application. First application is at OPC that allows communication between the different Festo software such as Fluidsim and Codesys or Tiaportal.
Oh, okay. So you can connect.
Ciros.
So you can take your Tiaportal, so your Siemens, and you can speak straight into Fluidsim through Easy OPC. So you can run Easy OPC at the same time as you're running Fluidsim.
Yes, yes.
Okay,
and when
and
you
then
simulate
in Fluidsim, there's a little input-output block, if I understand that correctly, which then talks to Easy OPC.
Yes, yes. Which I will show.
Oh, cool.
Because we for today, to have this communicating with Ciros, we will use the same technique, which I will demonstrate, and then you will see how this can actually work with how one can actually go about with linking it with Tiaportal or Codesys.
Okay, cool.
Fantastic, thanks, Tricia.
It's a pleasure. So we are basically through with the circuit here. Now I think at this point, I'd like to show how one can see the impact of what we've done here on a real machine, which will be simulated in Ciros. But if you have questions, then let us talk about, well, ask them now, or otherwise I will continue. Now, what is important is for us to remember that this is basically here, this is independent from the real machine. Now we need to make it dependent on the real machine. And how do we do that? We're gonna take these out because the real machine has these limit switches, it has the start and the stop and so on. So we do not, we cannot have two duplicated inputs, for example. We can do that and use an AND function, but to make our life simple and to make our program or our exercise a little less convoluted, we're gonna stick to using the real the IOs from the inputs, excuse me, from the real machine, which is inside in Cirros. Now, at this point, what we need to do is we need to bring these modules for communication with EZOPC, which here they are. So we have outputs and we also have inputs, Fluidsim inputs and outputs, and we also have analogs. But to make our life less complicated, we will not we're not going to use analogs for now. We will use digitals. So you can see that here I have 1 byte of inputs and I also have 1 byte of outputs. So for this exercise, because I will be using the control panel and the station, I'm going to have 2 bytes of inputs and 2 bytes of outputs. Just need to make it a little bit bigger. So this is the thing. This module here allows communication, Fluidsim to communicate with a real EasyPort, which this EasyPort can be connected to anything, such as an electro-pneumatic circuit or a real MPS station or whatever. So this is the setting here. So this is going to use a COM port, which is a USB that will be connected to the computer. Now, one can also decide not to use the real EasyPort and use OPC instead. And this OPC will then use EZOPC application, and with that you can use let me show you here, you can use step 7 or you can use here we are. So you can choose a PLC sim, which is basically the Siemens step 7 software. Codices, so you can choose to use Codices here, but for this we're going to use Virtual PLC because Virtual PLC is one that links to Cirros.
Is Virtual PLC then the GRAFCET PLC that's running in Fluidsim? Is that what's meant by Virtual PLC? Or is this
No,
just creating a bridge into between Fluidsim and Cirros?
So Virtual PLC, basically it's here. I
see. So it's a virtual controller that sits in the middle, pretending to be a PLC, and you
precisely.
can say it's coming in via. Okay, we're missing the Fluidsim there. Okay, carry on.
We have Fluidsim, here it is.
Mm-hmm.
So that it's coming
the process
via.
is...
Yes.
Okay, right.
Yes. So Virtual PLC can be S7 controller, or can be Codices controller, or can be an EasyPort, or can be a Fluidsim controller, which is the GRAFCET PLC.
I see, and it can work the other way around. So you can also have, let's for example, the S7 PLC sim controller going through the virtual controller into Fluidsim.
Precisely. So if I do that, you will see that I can select Fluidsim over here.
Aha, voila. Okay, cool.
Just one moment, I'd like to verify something here. Okay. So I need Virtual PLC EB1.
So EB1 means the entire byte.
Precisely. So this is input bytes for Virtual PLC, byte 1, address 1. So this is going to have to be 0 here. I can start with 0, but it's difficult for me to explain now why I'm starting with 1 instead of 0, but you will see later on why this is. So we do the same thing for the outputs. What is important though is that to note that for the outputs, it's not going to be E, it's going to be A. I don't know. So this is probably
It's
abbreviation
German.
for German.
Ausgang.
Yes.
And E
So
is German for Eingang.
Ah, it's like Ingang, Uitgang.
Exactly.
Okay, this is then going to be 0. Now it's just a matter of connecting all these different lines. So I'm going to move this solenoid valve to a side. It's nerve breaking because this is yeah, it's time consuming. Let's just be patient. You have to be when dealing with these things. I think I need to make it a little bit bigger than this. Two is better. They go in a straight line. I'll choose 2 for the rest.
And you're using 2 bytes because the MPS station requires 2 bytes.
Yes,
That's how many
I'm using
inputs
2
and outputs
bytes
it's got.
because the MPS station, there's the control panel, which is consisting of 1 byte of inputs and 1 byte of outputs, and the station itself, which has the different sensors, the conveyor module and the magazine module, which will occupy 1 byte of inputs and 1 byte of outputs. This is the reason behind this. So what if you were actually using, for example, Quadrisis or Step 7 as your PLC sim from Step 7 or from Tier Portal, then you wouldn't need GRAFCET PLC. What you would instead do is you would take the inputs here, you link them to the different sensors, and the outputs link them to the different outputs such as the solenoid valves, the lights, and so on, so that the PLC is controlling the circuit. PLC sim is controlling the circuit. In our case, it's not like that. We are using GRAFCET PLC to control the circuit and also to control an MPS station in Ciros. Almost done. There we are. So now the PLC program that we're going to write will control will actually control the virtual PLC, which in turn controls the MPS station. But now the question is, how do we then sort of synchronize this circuit here, which I've built, which will be the magazine module, double acting cylinder, the ejector. How do I then link it with, how do I synchronize it with the real magazine module inside in Ciros? So you would need to just connect this to the output. So I do remember that this is output number 4. So just like this, and the 0 volt. Okay, so now I will open Ciros. You can use education or studio.
What's the difference between education and studio?
So education studio is it's a more advanced version, so it's the same thing, exactly the same thing. It's just that studio is much more advanced than education. So education, for example, you can't save, while studio you can save. Studio you can edit models. Education you can't edit models.
So you can actually mess around with the MPS stations and create more sensors. And
yes, and put in your additional things that you may want to add, maybe a module or something like that. Yeah. So here we're gonna, let me just open the previous model because there's not, this is I haven't edited anything here. This is standard. If you go to open, or if you create a new project, you select distributing station, it will be the same as what I have here. What is just important is to remember to go to Model Explorer and then go to the properties of the PLC here, so that this PLC is linked to the, so you need to select OPC client here. And when you do that, this will then be visible. You go to OPC client, and then you refresh here, and you select EZOPC.2, and then you go to items, you connect. This will initiate EZOPC. And now we will look at so you will see here that the inputs are defined. So for example, this is, although they're not showing addresses, but it's just logical that the first input should be address bit 1, bit 0, and byte. So byte 1, bit 0. So here we have G1, BG1, which is workpiece at beginning of conveyor. This we now need to put in this information in Fluidsim, so that when we write the PLC program, we have reference in terms of what input does what. So just to do it quickly, I will come here. So one can label here so that we can see. So this is the station. This is, we can label this it's G, so G1, BG1. So this is workpiece at the beginning. So I'll say start or beginning. Let's use BIG. So this is workpiece at the beginning of the conveyor, although we will not use this variable, but it's good to have it. And then here we will have G1, BG2, and then we have BG3. So this is workpiece at the middle of conveyor. So middle of conveyor. And then we have at the end of conveyor, which will then be BG3. Now this is, you can see that G, now we're talking about the sensors on the conveyor. So you can think of G as conveyor, and then now we're going to go to C. So C1, C2, C1, BG1, these are the magazine module. So we're going to have C1, BG1. This is limit switch for the double acting cylinder. In our case, this is 1S1. So I can say retracted. And then we have extended, and then we have magazine empty. So this is going to be C1 BG2 extended, and we need to display it. And then lastly, we have magazine empty, C1 BG3, say magazine. Forget to tick display. Okay, so these are the inputs. Now we're going to go to the outputs. The outputs are not indicated like the inputs. This is because this is an educational software, so it is expected for the students to study the system, to basically turn on individual outputs to identify what happens, because well, that's part of learning. But because I know, I would just, to save time, I'm just going to quickly go here and label this. This is M1. So this is to eject workpiece out of the conveyor. And then output number 2 is actually the conveyor, so running conveyor forward. So I'm just going to say here K1, and then I'm going to say CONV conveyor for me to remember. Display. This is on byte 0, not byte 1. On byte 1, we have P1, P2, P3. These are the illuminators. So P1 is the start illuminator. So we have P1, and this is I'm going to say P1 start illumination. And then we have reset illumination, and then we have Q1, Q2. But let me stop here because I'm not going to use the rest, just to save time as well. Okay. All right, now we're at a point where, oh yeah, sorry, I'm almost forgetting this, the push buttons. So this is a S1. We have S2, which is the stop, normally closed. We have S3, which is the manual key. And then we have S4, which is the reset, S4 reset button. So now we need to finish our PLC program. So here we had, for example, input 0 and input 2, which obviously have changed. We now need to change input 2 because now input 2 has moved to input 12. So I need to update this conditions here so that we have 12 here. So we have start and input number 12. This is the conditions that if I press the start button and the cylinder is retracted, but also we need to have magazine. We do not need to have a situation where there's no workpiece in the magazine, but the magazine takes the other workpiece. So we need to have that as a condition as well. So this is going to be input number 14 here. And I believe it's a not because this is a normally, it's kind of like, it acts like a normally closed sensor. It's on high when there's nothing and low when there's something. So we need to say not here. I40. Now, also we want to indicate that the station, you may press the start button. So we will have an action initial step so that we illuminate P1, which is output number 0 here. So that when you press the start button and everything is in initial position, the start button will not illuminate anymore because we jumped to step number 2. At step number 2, this is when we need to take out a workpiece, which will then be output number 4 because output number 4 is linked to M1. So I need to change this to 4.
Treasure.
Actually, not 4. This is 12. Excuse me. Yes, Mr. Baynard?
How is the link made between the GRAFCET PLC and the GRAFCET drawing that you are drawing on the side? Does it automatically know? Does the GRAFCET PLC automatically know as soon as you start drawing the GRAFCET steps, it knows that that is its PLC program? You don't have to create a link between the two.
Yes. So for instance, in one Fluidsim project, you could have only one GRAFCET PLC, and so automatically when you have these steps, they link up to the GRAFCET PLC. This GRAFCET PLC here.
I see. So if you now draw a second GRAFCET program, if you've got two different programs running next to each other, it's not going to work.
I haven't tested that, but my assumption would be that there will be a problem. It will most probably try to read both of them, to try to run both of them, and if there's a conflict, for example, you're having similar outputs on both steps, there can be a problem there.
Okay, cool, thanks.
Now we're at a point where we turn on the output number 12, which is eject a workpiece. Now, when ejecting a workpiece, obviously the 1S2, 1S1 will turn off and 1S2 will turn on. And 1S2 here, we denoted it by a C1BG2, which is input 13. So here I need to change this to 13. So that we verify it, so that we jump to the next step after the cylinder is fully extended. At step 13, we obviously need to turn on the conveyor, and conveyor is input number 2. Not 2, but it's, output 11. Conveyor, output 11 there. Okay, and then the condition here should be that we've ejected the workpiece here, and conveyor then, okay, well, after the workpiece is fully ejected, it's on the conveyor, then we jump to step 3, conveyor runs forward of output 11. Once workpiece reaches the end of the conveyor, which is then going to be this one, C1BG1 end, which is input 11 on the PLC, then the PLC must stop, but the conveyor must stop. But the thing is, you don't want to stop the conveyor immediately, because then the workpiece is still on the conveyor. You want the workpiece to fall off of a conveyor. For that, we need to use a delay. I need to go here. I want it to be 2 seconds. And I want to use the output for the conveyor, which is Q11, as a delay. So we could delay it for even 3 seconds is okay. And input 10, which is that the workpiece is no longer on the conveyor. It's a funny condition. I'll explain it. I think it might have you confused or lost a little bit. This is the most trickiest part with this station, programming the station, is that the sensor at the end of the conveyor, it's a light barrier sensor, which makes it true when there's nothing and makes it false when there is something. But then we don't want to, let me go to the station and show you what I'm talking about. What is happening now? Okay, I'll try to explain it from this angle, but although it's not that visible. So what happens is that the workpiece comes out of the magazine, falls off of, goes on the conveyor. It's transported to the end of the conveyor, which is here. And there's a light barrier there. If we don't use a delay so that the workpiece falls off of a conveyor, or let us say goes on to the next station, which should be here, which will be here, then we have a material that's stuck here, and then we start a new cycle where workpiece comes out, and now you have 2 workpieces on the conveyor. So to just not to complicate it too much, we want 1 workpiece at a time on a conveyor. Then we need to delay. We need to delay the off state of the conveyor so that there's enough opportunity, or there's enough time period for the conveyor to travel up to the point where the workpiece falls off the conveyor. Now, using this input as a condition is very difficult, particularly with the type of programming that we are using. To say that, for example, I'll delay the signal from this sensor here. What happens is that when you delay that, when you use an on delay, an on delay requires the signal to be high up until the set time is actually 0. Now, if you do that, the problem is that the workpiece will be in front of the sensor, and then it will fall off the conveyor, and then your timer will not work because now the sensor has now changed the state before the workpiece, before it could actually count to 0, or before it could time to 0. So which is why you will see that I'm using this strange command here to say that I'm using the output, which is output 11, which is the conveyor, that the conveyor is running, it's high. So basically I'm delaying it. I'm using that as an input to the, or as an input to the timer to say I will delay the off state of the conveyor for 3 seconds, so that after 3 seconds the conveyor should turn off. And I'm using input 10 as a condition, as an end condition. And input 10 is actually a high state of the light barrier sensor at the end of the conveyor. We know that if there's no workpiece at the end of the conveyor, the input will be high. If there's a workpiece, it will be a low. So that if there's a workpiece at the end of the conveyor, we do not stop the conveyor up until there's no more workpiece on the conveyor. Now this needs to be tested. So now the start is here. So this is the start. Yeah, it's very slow to zoom, but this is the start button on the panel, which is what I'm going to use to control this circuit here. Now, I don't know why, but this message, okay, this message comes up normally because it says at least one easy port or OPC connection could not be established. Start simulation anyway. This is most probably because I do not have an easy port connected to my PLC, to my computer. However, OPC connection is 100%, so we will start simulation anyway. And I also need to start simulation in Ciros. So if we check the conditions, we have input 0. So input 0 is a start. If I press this here, input 0 goes on. And then I have end and input number 12. So let us see what is happening with input number 12. Input 12 is here. You can see that the input 12 is a high, which indicates that the cylinder is retracted. And then I have input 14. Input 14 is that, hello?
Yes, I was saying that I think there's a problem that there's actually no physical connection in the SSD between 2 and 3.
I'm not sure if I get that. Is it Ati? Ati,
Yes,
your sound is not very good.
Yes, I'm saying that on your Fluidsim.
Oh, I see what you are saying in the chat. Yes, you're quite correct. And also, this is because the magazine was empty. This is the connection here. Thank you, Ati. Okay. Very observant. So yeah, this is also because if you look at the conditions, not all of them are met. Yes, because you will see that magazine here, it's a high, which indicates that it's empty. Now, when I feed the magazine with workpieces, this should change state, and I should be able to start the system now. Okay. So workpiece goes on the conveyor, but in our case, the conveyor is not running. So let us see why. Now you will see that Q11, let us verify the output. Conveyor is not Q11, it's actually Q10. So I need to update this as well. So there's a workpiece stuck on the conveyor, and I don't want this. I want to start with nothing, everything clear. So this is the reset. It clears everything. So I'll reload again the magazine so that I can start the process.
Tricia, Hannes there?
Hello, Hannes, hi.
Yes. I'm very sorry. I have to leave because the electropneumatic webinar is finishing now at 11. I just need to say goodbye to the guys that's on the webinar at the moment. I just I've got one question. This is extremely interesting and I think value adding and something that we can use. Would in the same way that the participants are downloading Fluidsim currently, would they be able to get Ciros and all of this software so that we can simulate, we can do, for example, the PLC training or mechatronics training on something similar, or would they need licenses for the software that you're using now?
So
someone from outside.
There's a demo version of Fluidsim that can be downloaded on the Festo Didactic website. We also do have a special where.
Yeah.
Ciros, I also know that with the special offer until end of May, it's free of charge for use, no license required. So it's just that I have no idea, to be quite honest with you, how one would go about to get this this special offer, Ciros, because I don't know. But it's if someone really needs it, yeah, okay.
Sorry, host.
Chat with David or Chris or any one of the sales engineers. Ciros is available free of charge for a little while still.
That's fantastic. I think we can take the same route as with Fluidsim. It could be a great marketing tool for Ciros and Fluidsim.
Great, thanks, Hannes.
Thanks, Trevor. Sorry, I had to leave, but very nice. Thank you so much.
Pleasure.
Thanks for joining, Hannes. Cool. Can you just show the MPS station running again, Treasure?
Yes, yes. Okay, so I'm gonna clear the station, start simulation, load magazine module, start, workpiece comes out, conveyor runs, workpiece falls off. Okay, let me run it in full screen so it can become clear. So start, a piece is pushed out of the conveyor, falls off of the conveyor. And we can, this is the good thing. With Ciros, there's no sound, you know, like in real life when a cylinder extends, there's a sound, and then there's also air and the conveyor motor runs, so you can hear the sound. Ciros unfortunately doesn't have this, but the good thing is that Fluidsim has it. So when I press start here, we're hearing the sound of
you're hearing Fluidsim in the background.
The cylinder from
That's
Fluidsim.
cool.
Yeah. And indeed, you will see that if I press the start, the cylinder actually extends in Fluidsim. So this is a good way to show the relationship between a real machine and a circuit diagram. Okay,
so you
that's
can actually show students this entire thing completely virtually, so you don't need an MPS station. So while we're on lockdown, you can run complete mechatronic exercises completely virtually.
Precisely, yes.
Which also means you can take, if you have one MPS station, you can have 20 students in the classroom running this on PCs, and then when they're good on the PC, then they can switch to the real MPS station to try out their programs.
Yes. Yes.
So Cyrus is a multiplier. You can multiply the teaching potential you have. You buy one MPS station and then you buy 20 licenses of Cyros.
Yes. And I actually support this because, you know, there's, when you have a lot of hardware, there's also a lot of work that needs to be done, because especially when you're having students working on the machine for the first time. I mean, if you see what happens if something is not working, for someone who is inexperienced, problem can be anywhere, and they would start to fiddle with everything, the mechanical assembly, the wiring, the sensors, and they damage lots of things. But if you start them off with Ceros and they work on a virtual machine, I mean, there's no way that they're going to break this MPS station in Ceros. So it will prepare them to basically understand and be able to write a full functional PLC program before they move to the real machine. That way, there won't be any problems such as fiddling too much with the unnecessarily with things.
That's a good point. So they can get their learner's license on Cyros before they get the driver's license on the real MPS station. Cool, I like it.
Yes. Great. So yeah, now I'm using 2 applications. So question is, can we use a third application? Like instead of using GRAFCET PLC, could I then use a, for example, Ceros, Fluidsim, and Codesys and Tier Portal? The answer is no, because if you look at the limitation, this is, I cannot select 2 clients. I can only select 1 client at a time. Because basically Fluidsim and Ceros are doing almost the same thing. They are simulating something. They're simulating a PLC program or simulating your circuit. So ideally you should be using one of them. You should be using Ceros with the programming software, or Fluidsim with the programming software. So this was just taking it to a high level, basically, where we would use both simulations together with a PLC program, one PLC program, which would have to be GRAFCET PLC. Yeah. One way to have a PLC program, for example, if you want to use both simulation, we are simulating a circuit diagram, you're also simulating a real machine, and you want to use a real PLC program such as Codesys or Tier Portal, then that way you would need a real PLC, because you would use an easy port which you can link both applications to, and then that easy port will then connect to the PLC, and then you would use a second computer to then program that PLC, which will exchange the IOs with EasyPort, so that EasyPort will then feed that data to both applications. Both applications, I mean Fluidsim and Ceros. Great stuff. I think
thanks, Treasure. And any questions from the floor? Nicholas at UJ, have you got Cyrus? Have you got MPS stations? Have you got Fluidsim? And do you see this working? Nicholas, do we have you online? Maseko, what do you have? Do you see this working? Hi, Maseko, I can see you've unmuted, but I don't hear you, strangely enough. Now I see you muted again and unmuted, yeah. But I can't hear anything, oddly.
Mr. Maseko, perhaps write in the chat, because I think it has to do with your audio settings. If you can just type your response in the chat. Alternatively, you can go to settings. If you are able to, you can go to settings and then go to microphone, change between the two. There should be microphone array, there should be stereo mix. choose microphone array. That should resolve the problem. Yep. So great stuff. Any comments from the floor? Can you see the use for this in your situation? Nicholas, you haven't commented there. Are you also having a sound issue or something?
Let's try Martinez. Martinez, do you have Cyrus and Fluidsim running already? I want to make sure we make use of this free offer while we still have it. It's the end of May, to make sure everyone has Cyrus, the free version, to test it out.
Horst, no, I don't have it, but I got the link from Treasure, so I'll be downloading it through the day to at least try and, you know, get simulating on it.
Very good. I think it's a wonderful tool, especially now in coronavirus, to be able to show what you can do with virtual reality. You certainly get a lot of interest when you say virtual reality. They go, ooh, what's that? They go, oh, look, virtual reality MPS stations. Wow, that's so cool. So it's also a great tool to be able to get to students and show people what's possible in this fourth industrial revolution. Yeah, and get in touch with Chris
Exactly.
to get hold of a free license for Cyrus. Also
Yes,
for any
I'll
other
do
customers that you're dealing with.
Yes, I'll do that. And the advantage of it is I can at least show the mechatronic stations and the simulation of it to the colleges that I represent in my area, you know. So in that sense, it will make it easier for us to at least apply the sales technique as well of this system.
Exactly. You can do a virtual meeting. You don't have to drive out there to Okanja. You can show them virtual meeting. Let me show you quickly what's possible. Show a video of a real station. Show the virtual reality. Show the control of it. And then the discussion starts.
Yeah, no, I agree. And I mean, why not make use of it while you have it at the point of your fingertips, you know? So and with this lockdown, the big advantage is, you know, we all got exposed to these type of technology available to us, and it just opens up doors to the future. So I see no problem in using it.
Very good. Robert, what do you think? Do you see being able to get in touch with people with a virtual reality like this?
Hello?
Hi, Robert. Yes, I can hear you. Oh, I could
Yes,
hear you for a second. Yes, I can hear you now. Thank you.
these apps is very better for here in Rwanda. For Fluidsim, it's very needed in especially in Rwandan education. For example, in the industries, example in the breweries here in Rwanda. So it's so important here in Rwanda. Yeah.
Brilliant. So get in touch with. Have you got Cyrus? Have you got the free license of Cyrus at the moment? Robert, do you have a free license of Cyrus? Well, you can get in touch with Kim to make sure that you get a free license of Cyrus before the offer expires end of this month. Great, thanks, Treasure.
It's a pleasure. I think this is Mr. Maseko, probably something's wrong there because we don't have any response from him. But thank you very much, everyone, for your participation. And I wish you best of luck with your future in codices and Cirrus and so and everything else. And yeah, I'm looking forward to hearing from you about the projects which you would have done with these applications.
Here there is a question, Mr. Treasure.
Yes, Robert.
Yeah, my question is this. I'm asking if it can be possibly to learn at the same time hydraulic and pneumatics in the same Fluidsim version. Yeah, it's my question. Yeah.
Okay. There's basically 3 Fluidsim software. The answer is no. So you wouldn't use the same software installation to do those. But there's Fluidsim hydraulics, Fluidsim pneumatics, and Fluidsim electrical. So if you would want to do almost the same exercise, for example, but use hydraulics, then you would need to install Fluidsim hydraulics.
Okay, thank you.
You're welcome. The Fluidsim P, Fluidsim H, Fluidsim E, Fluidsim electrical. I have them here, so let's see Fluidsim. So there's also Fluid Draw, so you can see this is Fluidsim. My bad. So yeah. So there's Fluidsim 5. So there's pneumatics, there's hydraulics, select technologies, there's Fluidsim electrical engineering. So this is for advanced and complex electrical circuit. Although you can, build electrical circuit in Fluidsim pneumatics, there will be limitations. Some libraries are not available. Some electrical libraries are not. There's limitation in terms of electrical libraries. I have here they are. So let me close this. So there's electrical controls. While with Fluidsim electrical, there will be more of them. There will be more of the different components. With Fluidsim hydraulics, then you would have electrical controls, and then you will have pneumatics, hydraulics, which will have the different components, such as here, but hydraulic. Great.
I see the Ciros free license is available until the end of July. So it's not until the end of May, it's until the end of July. So we still have a bit of a window to get this out and try it.
Yes. Well, I think that's pretty much about it, because I am through, and if there's not any more questions, then let us end this webinar. And yeah.
Great, thank you, Treasure.
Thank you. Goodbye, everyone.
Bye.
Bye.
Thank you, Treasure.
Bye bye and thanks.